So if you want to come back and look at it, because when I record this, I'll put it on YouTube, and then it'll record at a decent quality, and maybe hopefully that'll be easier to see. All right, so we'll graph this one. We're talking about the first quadrant. We have a couple of little lines. Now to graph that particular one, get y by itself. So that's going to give us y is greater than or equal to a negative x plus 2. So we start at 2, we go down 1 over 1, down 1 over 1, and we get, now this is bigger, so I'm shading up. And the big thing you have to do is find the region you're talking about. And this region we're talking about is here. Because every single one of these problems is going to have a region, and you have to graph it, the whole part of this, graph it, find the region, and then, all right, so I said there's 3 parts. This is a big part. I need to make sure this part, because this part is relatively easy. Because if this part isn't easy, the rest of this stuff gets absolutely hideous. All right, so, all right, are we okay, put thumbs up or not, are we okay, given this, you can come up with this picture? Does this seem easy, right? Okay, if this is easy, then I can build on it, okay? So now, here's the next part. This next part is, I'm going to throw out some sort of equation. And I'll say z is equal to 2x plus 3y. All right, so when I did this example in first period, someone said, how do you come up with this? I have to give this to you, right? So now I'm going to start using some terminology. These things are called constraints. All right, why are they called constraints? They sort of are our restrictions. These are our restrictions. These restrictions come up with this picture. This picture, right, is, this is called our feasible region. Okay, what does that mean? I don't know yet. We'll talk about it, right? This other equation is called your objective. It's actually called your objective function. Okay, now, math people are not super creative when they come up with things. They're called constraints because they're restrictions, okay? And when we start looking at a word problem, I'll talk about what restrictions are, and then we'll say, here's our restrictions, and our restrictions are going to come up with these inequalities. These inequalities are going to create a picture that gives us our feasible region, right? And when you have a feasible region, this is basically everything that works, right? Then our next little part is called our objective function. Our objective function is our goal. What's our objective? And our objective is, it's always one of 2 things. Either I want the biggest number possible or the smallest number possible. That's how it works, right? So here's my objective function. In this case, I want the smallest number possible. Now, what does that mean? Well, if you look at this, it's got z is defined in terms of x and y, right? And for different values of x and y, I'm going to get a value of z. And in theory, here's what you're supposed to do. See this little shaded region? It's got a whole lot of coordinates. It's got this coordinate, it's got this coordinate, it's got this coordinate, it's got these little fraction coordinates, it's got all sorts of coordinates. And in theory, what we're supposed to do is plug each coordinate in this mess into our objective function, and in this case, I want the absolute smallest number. Now, in practice, it doesn't make a whole lot of sense to plug in every single coordinate. What you really want to do is you want to plug in extreme as sort of like your boundary points. Because if we're looking for the minimum value, pretty sure the minimum value is not going to happen in the middle of the picture. The minimum value is going to happen at the edge of the picture. And not just any edge, it's going to happen at wherever you have these corners. And so these corners are important. So we're going to call those boundary points. And why are they called boundary points? Well, they're points, and they're on the boundary of our feasible region. And so I'm going to write down my boundary points. So when I write down my boundary points, I've got one boundary point at 0, 2, another boundary point at 0, 5, another boundary point at 2, 0, another boundary point at 6, 0, and another boundary point at 6, 5. And my claim is, if I can find, when I plug, instead of plugging all of these points in, because there are an infinite number of points, if I just plug in these boundary points are going to give me my extremes. They're going to give me my absolute max and absolute min had I plugged in everything. So, we're going to plug in. And when I plug in, let's see. When I plug in...
Is the last point 6.5?
Yes, 6.5. So, I'm going to plug in 0, 2 into my objective function. So here's an x, here's a y. If I plug in 0 and I plug in 2, well, 2 times 0 is 0, and 3 times, so that's going to give us 2 times 0 plus 3 times 2, which gives me a 6. I'm going to plug in 0, 5, so it's going to give me 2 times 0 plus 3 times 5. 0 plus 15 gives me 15. I'm going to plug 2 times 2 plus 3 times 0, which is going to give me 4. I'm going to plug in 2 times 6 plus 3 times 0, which gives me 12. And then I'll plug in 2 times 6 plus 3 times 5. 12 plus 15 gives me 27. Now I look at this, now at the end of the rainbow, at the end of the problem, I get to look at all of these numbers, and now I have to answer the question, what's my minimum value? Right? Actually, usually I'm going to ask, what's the minimum and what's the maximum value? And so if I say, what's the minimum value? You say, well, there's the minimum value. And if I say, what's the maximum value? You go down and say, oh, there's the maximum value. All right. And this is where I'm focusing. This is where my goal is today. My goal today is I'm going to give you this and this. So I'm going to give you the constraints. I'm going to give you the objective function. And your goal is, how do you find the minimum and maximum values of a given situation? And to do that, just going to repeat again, you get this gives you this picture gives you these coordinates, and these coordinates you have to plug into the objective function, which give us a number. And we're looking for either the biggest or the smallest number. And so there's our biggest, there's our smallest, and then I may ask, like, what causes it? So the coordinate 2, 0 gives me my smallest, and the coordinate 6, 5 gives me my biggest. All right? Okay, are we kind of okay with the procedure? Right now you have no clue why we're doing any of it, but if I give you this and I give you this, can you give me these numbers at the end? That's what I need, right? Yep, okay. That's the skill, right? If you can do that, right, then I can do the next part. But I've got to make sure you can do this. Yes? Are you just, all right, okay, you're good? All right, now, so let's try it again with numbers that are pretty typical with our word problems. So now I'm interested in x greater than or equal to 0, y greater than or equal to 0, because they're always there. Then I want x greater than or equal to 15, y less than or equal to 5, and x plus y is less than or equal to 25. And my objective function is going to be z is equal to 0.06x plus 0.09y. So here's what I need everybody to do first. Given this system of inequalities, graph the feasible region, right? I want a picture. After you graph the picture, show you the region, write down the coordinates, and then we're going to talk about this. And when you get that far, like once you draw the picture, do the hand raise, and then we're going to talk. I'm going to hit pause.
I have a question.
All right. So it may be helpful to change how you count on your grid. Like for me, instead of counting by ones, it looks like counting by fives is going to work out really nice. So when I look at this, I could just say, and if I'm counting by fives, this is a 5, this is 10, this is 15, this is 20, and this is 25. And the same thing, if you're going on the, one thing to keep in mind is if you're counting by fives on the x, count by fives on the y's as well. So there's 5, there's 10, there's 15, there's 20, there's 25. And this will make your life, at least the picture, more manageable. Because if I didn't count by fives, then I'd have this giant picture and I'd run out of room. Oh, shoot. Now, when you graph your feasible region, your next job is to find your boundary points. And so my boundary points are going to be 0, 0, 2, 0, 0, 7, and 4, 3. Because all of these are going to require a boundary point. Now if I scroll down, they're saying like find the intersection point, the vertices, and at part C it says what values of x and y maximize profit, or whatever. They want to maximize this thing. So if I'm trying to maximize this thing, that means I have to plug each one of these points into this. So well, if I plug 0 in, that's going to give me 0. If I plug 2, 0, it's going to give me a 6. If I plug 0, 7, that's going to give me 14. And if I plug 4, 3, let's see, 3 times 4 plus 2 times 3, 12 and 6 gives us 18. And so my job is what maximizes, what's my biggest number? My biggest number is 18. So if I wanted to maximize P, the maximum of P is 18. What causes that is 4, 3. Now, your homework. I gave you I could have signed something out of your book, but I typically just don't like, the numbers in your book just seem to be pretty ugly. So I gave an assignment, it's due Thursday. The reason it's due Thursday is tomorrow and Wednesday we are doing iReady. And I talked about it last week, I got to talk about it now. We've got to do it, we've got to spend 2 days on it. They say a lot about 90 minutes, so that's 2 class periods. If you don't finish in those 2 class periods, you need to finish. And the reason you have to finish is if you do not score above a certain amount, you will be labeled as needing remediation. And if you are labeled as needing remediation, that means you have a bunch of math problems that you probably don't need to do that they're going to make you do during flex. So, tomorrow and Wednesday, I know it's boring, and you might look at some of these questions and go, why on earth do we have to do these? I don't know. Fulton County pays my paycheck. They tell me I have to give it to everybody. That's what I'm doing. Do I think it's a big waste of time? Probably. But That's what we have to do. Then Thursday, my main focus on, so I asked you to do the odds. My main focus on Thursday is going to be, I'm literally just going to start off with 5 or 6 word problems. And I'm not even going to, the whole point of Thursday is, given a bunch of words, how do you get your constraints? How do you get your objective function and your constraints? That's where I'm focusing on Thursday. And then Friday, we're going to put it all together. And then we have Tuesday when you come back, that's a review day. And then your test on Wednesday will be word problems. It's probably going to be, I have to figure out how I ask this, because it's kind of double jeopardy when I ask one of these questions. Because if you don't set up these questions, if you can't get these equations right, then your picture is going to be ugly and it's just going to be a pain. So I have to ask it in such a, I have to ask these questions in such a way where you're not really answering one complete question, you're just answering parts of different ones. And then I'll probably have a couple of word problems like what I had on your quiz. And that'll be your test. If there's time, I do need to go over your quiz. I don't know if I have enough time to do it today.